That's what calculus is, the study of slopes. That's all it is. So today we are talking about average rate of change. Average rate of change, which basically is a slope. Now, you guys have been learning about the slope of a line since like 7th, 8th grade, right? And my 5th grader actually had a question about slope, though she didn't know what it was, and but she, oh, that's why it's, all right. Anywho, so we've been talking about slope for a super long time, and it turns out that slope is basically everything. It's calculus, but beyond that, it's stock market. It's the whether or not we're going into a recession. All right, it's the prices of homes. It's all of that, and it all is just about slope. Most things are about slope, it turns out. So not only can we find the slope of a line, which is a very nice slope, but we can also find what we term the average rate of change of a function, which we might think about like the average slope, okay? But of a function, not just a line, so it's going to be a curvy thing. So just to remind ourselves, do you know the slope formula? Rise over run. So yes, slope is rise over run. If we can count it, that's great. What about the formula for it? That is slope-intercept form, which is what everyone remembers from algebra. That's the only thing. Y2 minus, there it is. Yeah, there we go. Holy moly. It's been a long time. So we can do this a couple of ways. When we're looking at a graph, it's really easy to count the slope. We're going to start on the left point here, and I'm going to go, I got to go up how many? 3. I got to go to the right how many? 4. So our slope is up 3 to the right 4, or positive 3/4. On number 2, again, they've highlighted points for us. We always want to start at the left point. So if I start at that left point, I got to go down how many? Down 8, and then I got to go right 4. So that's a slope of down 8 over 4, which means that's the slope of negative 2. What's the slope here of number 3? 0. It has no slope. It is not changing. It's not going up. It's not going down. It's 0. It's right in between up 1 or down 1, okay? So it is a slope of 0. Okay, so that's easy when we have just a graph to look at, super easy. But if we have ordered pairs, then we're going to use our formula, which would be y2 negative 7 minus 3 over x, which is negative 5. Negative 9. Remember, this is x1, y1, sorry, x2, y2. So we subtract the y's, negative 7 minus 3, and we subtract the x's, negative 5 minus the negative 9. You do have to be careful. Order does matter, which really just means you have to start from the same place. So if I subtract my y's this way from the right side to the left, I'm going to do the same thing with the x's from the right point to the left point. So make sure you go the same direction. Let's see, negative 7 minus 3 is negative 10. Negative 5 plus 9 is 4, and so we get negative 5 halves. All right, so on number 5, we're going to do the slope. What should I write down? Negative 4 minus negative 1 over? Good, excellent. So again, minus a negative is really plus, so negative 4 plus 1 is negative 3 over negative 9, which reduces to negative divided by negative is positive 1/3. Very good. Okay, that's excellent. Do we need to do the last one? No. Okay, great. So now that we remember slope, for a linear function, slope is constant, meaning between any 2 points we could pick, anywhere on our lines, on a constant, a straight line. The slope is the same. It's negative 2, always, always. between any 2 points, even crazy ones. And so for nonlinear functions, the slope changes between different pairs of points. Any 2 points that you pick on the curve are going to have a different type of slope. So for instance, if I were to pick this point and this point, I could find a sort of slope between these 2 points. And if you look at that slope, is that a positive slope or a negative slope? It's a positive slope. But if we look over here, these 2 points that they've drawn in, is that a positive slope or a negative slope? It's a negative slope. And so between any 2 points, we have a different slope. And because of this, we can find what is termed the average rate of change. We don't call it the slope exactly. It's an average rate of change over a particular interval. So the average rate of change of a function between 2 points is the slope of the line that passes through those 2 points. This is called a secant line. Now, I don't know if you remember from geometry, most of you, if we had that whole unit on circles, and if you had a line that just touched, do you remember what that was called, what that line was called? Tangent line. Very good. Okay. But if we had a line that hit and intersected the circle in 2 points, that is a secant line. Okay. So tangent means to touch, and secant means it's touching in 2 places. And so this is called the slope of a secant line. And the formula for the average rate of change of a function, okay, we're going to do this together. When I have, this is a function, okay, I'm going to call, this function has the name f of x, okay, generic function f of x, and I have this point here, b, which hits right here, and if I gave it ordered pair, I would call this b, and then using function notation, this is my function evaluated at b. So that's what we call the y value. The y value is the function evaluated at that number b, okay? If we actually knew what the function was. All right, in here, what would this ordered pair be called? A and then f of a. Yeah, the function evaluated at a. And so that's fancy language. We're going to call this the slope of a secant line. So again, a secant is the slope between any 2 points. The slope of a secant line, then, is really just our slope formula. But it's no longer called y2. Now we're a little more specific. The y value is f evaluated at b minus, what's our y1? F evaluated at a, f of a, all over b minus a, x2 minus x1. So all we're doing is sort of rewriting it using new fancy language, okay? So this, again, is just y2 minus y1 over x2 minus x1, but they have new stand-ins, okay? New actors. So this is average rate of change. It's just slope, but a little fancier, okay? So let's look at these examples here. Given the function graph below, find the average rate of change on the interval. This is an x interval, just like here, the interval from a to b on the x-axis. So what they've given me here is they're giving me an x value of -2, so we're starting at -2, and we want to end at 1 on the x-axis. So these are just x values that they're giving us. How do I figure out the y value? Yeah, look them up. So here we go to -2 on our x-axis right there, and the function is right, there's the point right there. So what's the ordered pair? -2, 1. Very good. All right, and then we go to 1 on the x-axis, and then oh, there it is right there. What's that x value? -8. Is it -8? 1, 2, 3, 4, 5, 6, 7, 8. It is. Oh, this is a 10 by 10 graph now. Who knows? Okay. All right, super. Now that we have our ordered pairs, the slope of the secant line is just going to be Negative 8 minus 1 over 1 and minus a negative 2. Be a little careful. 1 minus the negative 2. All right, so 8 minus 1 is negative 9. And 1 minus a negative becomes plus, so that gives us 3. And that reduces to? Negative 3. Beautiful. All right. So on number 8, same thing. They're giving us the x values of 0 and 4, and we need to figure out the corresponding y values. So let's see, 0 is negative 7, and 4, 1, 2, 3, 4 is 0. All right. So the slope of the secant line between the two blue points. So we could actually draw that in on this one. It's a little easier to draw. Oh, I missed. Okay, but there it is. So this would be the average rate of change between the 2 points. What am I going to subtract?
0
Good. Over? 4 minus 0. Beautiful. Minus negative 7 becomes plus 7, and 4 minus 0 is 4. Oh, wait, what is wrong here? Never mind, we're good. What is wrong? Nothing. It's fine. Okay. Right? Our points are right? Okay. Hers is different. She has an error. It's like, wait, what? Okay. Questions so far? Okay, now you're going to learn the coolest thing ever about your calculator. Okay. So in real life, our pictures, we don't always have graphs to look at to make it easy to identify the points. So instead, they give us an equation. And so here's our function, and just to remind you, the slope of a secant line, we had ordered pairs A, f of A, and B, f of B. And if we apply our slope formula, that would be y2, f of B, minus f of A, over B minus A, okay? So now we're applying the slope formula, but with function notation. And
how do you know if it's like the one in the bracket, the number of the always goes back to
it is always, anytime we talk about an interval, we're always talking about an x interval on the independent variable, the variable that our function's based on, okay? So what we want to do then, for this particular function, I'm going to show you, it's really, really cool, but I want to write it down first. We're going to use these x values, so that's going to be f of 2 minus f of negative 1 over 2 minus a negative 1. Okay. All right. So that's the nice part. Here we go. Are you ready for this? Our calculator, instead of us having to go by hand and plug in a 2 and plug in a 2, and 2 squared is 4, negative 4, plus 12 is 8, minus 4. Do you want to do that? I don't want to plug it in and figure it out. So here we go, ladies and gentlemen. We're going to go to y equals and plug in the formula. Negative x squared plus 6x minus 14. Okay. Put in your formula. Your calculator does function notation. It's very cool. And so go second quit. All right, second quit right there. All right, now your calculator does function notation. We were in y1. I think you have to do alpha f4. Yeah, oh, there it is. Okay, alpha f4. Taryn, I don't know if yours is going to get me there. Did it work? Yeah? Okay. Alpha f4, we get this menu. Alpha f4? Yeah. Alpha f4, we have this corresponds to all the y values in the graphing menu, okay? And we were in y1. So we're going to hit y1, and then we can evaluate it at 2. And so you just use parentheses, and what it's doing is it's using the formula we have in y1, and it's plugging in the 2 for you. And we get an output of negative 6, which is super nice. So that f of 2 is negative 6. What did you get? Did you not get it? Did you type in your function right?
When we set one,
Did you do the parentheses?
I'm here.
Oh, do second quit. Quit. All right, and now do alpha F4. And hit number 1 there. Yep. And now do parentheses 2. Did you get it? There it is. Oh, negative, not subtract.
Oh, yeah.
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 Okay, there we go.
Thank you.
Yeah? Good? You got it? Got it now? Okay, good. Okay, so that gives us our y dot, and then we just can do it again, alpha F4, and do negative 1. And we get, so minus the negative 21 over 3. Let's see, that becomes negative 6 plus, I don't know what that is, negative 6 plus 21, 15 over 3, which is 5. Okay, function notation is pretty cool, but yet there's another way we could do this. There's so many ways. Let's try. You looked at the table? Yeah, absolutely you can use the table. Absolutely you can use the table. So let's go back and try number 10. Let's see, we are doing the slope of the secant line. This is going to be our function evaluated at negative 7 minus f of negative 9 over negative 7 minus the negative 9. I'm showing it to you this way for a very specific reason, and this is because this earns you full credit on the AP test. All right, 2x squared plus 28x plus 93. So we can also just graph it, and I think you can just type in negative 7. Yeah. Oh no, you can't. You have to go to trace. Can you do it then if you hit trace? Yes. Okay. So if you hit trace, then you can just type in x values. So negative 7 gives us an output of negative 5, and then negative 9 gives us an output of 3. So that's negative 8 over 2, which is negative 4. That's pretty fast. I like that best, I think. Now, there is an issue. It won't work for numbers outside negative 10 to 10. You'd have to change your window. Okay. Okay, let's try something a little more harder, like number 13 and 14. Okay, so let's do 13 and 14. So I'm going to type in here. Now, you guys like to do the whole fraction thing. I just use parentheses. When you have a fraction, if you just put parentheses around your numerator and your denominator, it works great. Works great. Okay, so the slope of the secant is f of 8 minus f of 2 over 8 minus 2. I'm going to graph that sucker. Rational fractional function. And then I'm going to do trace, and now I can type in my values. 8 gives me, 0.5. And 2 outputs a negative 1. And so I have 0.5 plus 1, which is, 1.5 over 4. Can you leave an answer, 1.5 over 4? How is it? 8 minus 2? Those are our x values. 8 minus 2 is not 4. It would be 6. That'd be a better, that's math here on Earth. Yeah. Thanks. Sorry. All right. We wouldn't want to leave an answer like that. 1.5 divided by 6 equals 0.25. Good so far? You fine? You doing good? You okay? Y'all are quiet. Which is a far, far change from my last class. All right. Square root of x plus 5. Oh, let's see. Yeah, I think that's okay. You know what? I think this one's actually okay to do by hand. Maybe. So I'm doing f of 7 minus f at -1 over 7 minus a -1. This one's actually not too bad to plug in. If I plug in a 7, that's just the square root of 12. And then if I plug in a -1, 4. Oh, well, we'll get there eventually, yeah. So square root of 4, all right, and the denominator is 8. All right, this is a lovely exact answer, but we can approximate it. Radical 12 minus radical 4, which is just 2. 1.4641, blah, 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 over 8, which is 0.183, approximately. Yeah? 0.18, yeah, squiggles, is that what you said? Squiggles, approximately, yeah. Little squiggles, okay. All right, questions for me on those? No? Okay. So 15 and 16. Number 15, I'm not going to do the whole thing because it's quite the same thing. A company's total cost, C of X, in dollars to manufacture X units is given by this function. And we want to find the average rate of change of the total cost for the first 200 units. So that would be on an interval from 0 to 200. That would be the first 200 units. How come it's not 1 to 200?
Because there's a number between 0 and 1.
There's a number between 0 and 1? If you subtract these, it's 199. If you subtract these, it's the 200. Yeah, okay. All right, and so all we would need to do to find the average rate of change is that slope of a secant line. And so we would plug our x values into our c function. So c of 200 minus c of 0 over 200 minus 0. Those are our x's, yep. The first two, because that's what it says, it's x units, and we wanted the first 200 units, and remember a unit, those are the x's. So those are the first 200 x's, okay? All right. Cool. And then you would finish that up, but I'm not going to do that. Okay. A ball is thrown straight upward so that its height in feet is given by this equation, where t is time in seconds. Ladies and gentlemen, on these kinds of problems, I always like to look at a little picture. It says t is time in seconds, and if you look, normally our equations say y equals x's, right? Normally it's y equals, okay. So we have to replace, we don't have an x-axis, this is our t-axis, our time in seconds, and we don't have a y anymore. Instead of y, we're using h for height. Okay, all right, so we have the height of a ball, and it's thrown straight up, which is very important. Does it, graphically, does it just go up and then down? No, it's a curve. Why is it a curve like this? Because time is passing, right? And so you throw it up, and time is continuing on. So it's like the picture of the ball every millisecond, all right? And if you looked at it, it would, so it's the height of the ball every millisecond. So time is passing. All right, find the average rate of change in the height of the ball from when it reaches its maximum height. That's right here. When it reaches its maximum height. Oh, I need to know what that time is where it reaches its maximum height until it reaches the ground. So here is where it's reaching the ground. So I need to do a little bit here. I need to figure out where it reaches its maximum height. I need to figure out the time that it also hits the ground. How do you want to do that?
do h of 0?
H of 0, if I plug in a 0, H of 0, if I plug in zeros, that's going to give me this point, certainly 0, 0. So how are we going to find the maximum? We have an equation.
Plug it in the calculator.
Oh, plug it into the calculator? Sure, let's plug it into the calculator. All right, so negative 16, I'm just going to use an x, not a t. So negative 16x squared plus 80x. All right, I got that in my calculator. And should I graph it, maybe? Woof, woof. All right, I'm not seeing the whole picture here. What do I need to do? Zoom fit. Zoom fit. Does that work? Oh, no, it's terrible. It's a terrible idea. Oh, yeah, it is no good. I'm going to go back. I am seeing my important x-intercepts. I'm seeing it there and there. But what do I need to see? The maximum, the y maximum. I'm just going to change my window and change the y maximum value. What should we make it? 100? Sure, let's try 100. So you change the y max to 100. Oh, look at that. There, that's lovely. Okay. All right, now, how do we find the maximum? Trace it? Calculate the maximum. Let's do that instead. Calculate the maximum. So we'll program here. We got to go to the maximum, and then we want to move Tinkerbell to the left a little bit. So you go left a couple bits, and you hit enter. And then right past it a little bit, and then you hit enter. And then you guess. So you move Tinkerbell back to the maximum, and you hit enter. And so the max occurs at, what number is that? 2.4999999? 2.5. It is 2.5, and the max is 100 feet. So 2.5 seconds is how long it, wow, that was in the air a pretty long time. 2.5 seconds to reach the maximum. And then, what else did we need to know? When it reaches the ground. Well, it reaches the ground when it's got a height of 0. If it took 2.5 seconds to get up there, how long is it? Yeah, another 2.5 seconds to get down. All right. So that is 5 seconds. So we want to find the average rate of change. So again, that is the slope of the secant on the interval from 2.5 seconds to 5 seconds. All right, so we want the height at 5 seconds minus the height at 2.5 seconds over 5 minus 2.5. What's the height at 5 seconds? 0. And what's the height at 2.5 seconds? 100. And then 5 minus 2.5 is 2.5. And so that's negative 100 divided by 2.5. I know what that is. Decimals was my first F in math ever. Negative 40. Negative 40. Negative 40. Does anyone know what that actually is, the negative 40? This is what's really cool. Our numerator was height. What was our height unit? Feet. It was in feet, yep. So we had height on the top, that's feet. And then, what were we subtracting in the denominator? Seconds. And so if we carry those units, then this is 100 feet in 2.5 seconds, which means negative 40 feet per second. Very good. Yeah, feet per second. All right, ladies and gentlemen, do you have any questions for me?
Yeah.
What's
the answer on the answer key?
For 15? $50 per unit. Did you get that? Yeah, good. Cool.